So hello everyone, in this video you will learn basic vector geoprocessing and 3D visualization. First, you must go to this website, scroll down and find the save file data, then download the track of Typhoon happen on West Pacific in the vector formats of lines. After the data has been downloaded, you have to unzip or extract the data. So this is the folders of unzipped files. Click the files, go to your QGIS, hold and drag. Here there are so many Typhoon tracks here, so we only need Nanmadol of 2022. So we do the spatial query using select features by attributes. Open the attribute table first, then click on this icon, select name equal to non-model, type here none, all unique, non-model, and happen on the season of 2022. 2022. Okay, expression is invalid, so we need to add expression here equal. Okay, now expression is valid, select features. Now there are 56 matching features being selected. We close this one and close the table. Go back to your layer, right click, then export the selected features only. In this case, I will use GeoPackage, and the projection I will use is UTM zone 52 north, and the name is non-model, like this. Okay, I already have, so I will replace, then click OK and overwrite the file. So we can zoom in to our layer here, and we don't need this layer anymore, so we can remove. You can change the symbology, double click and select evac neon, click OK. If you want to visualize using the maps, you can use quick map services. But in this case, first we want to use the OpenStreetMap to show the building location using QuickOSM plugin. Just type building here in Iizuka and click run query. Okay, finish. Now we have the building polygon around the path of the typhoon. So next we want to know which building affected. First we need to create a buffer. We go to vector. This is very basic geoprocessing methods. Buffer. Here we make a distance, let's say 300 meters to the left and to the right, and then dissolve the result and just click run. And now we have a buffer. We can zoom in. So which building affected? We can go to intersection processing tools, go back to vector geoprocessing tools and select intersection. So this is, you may select the roof, and this is the buffer area, and just click run. Now we know this is the building affected by the typhoon. Okay, very simple, right? Next, if you want to add some map, you can add the Google Road. Then you can make the visualization much better. So select the uh, here The opacity we set 60%. Okay. Another way, if you want to visualize in 3D dimension, you may go to this home page, PLATEAU by Minister of Land, Infrastructure, Transportation and Tourism of Japan, and then go down, you will find out the map and go to southern Japan, find Iizuka City here. Click here. If you cannot read Japanese, you can translate. Just right click on the web page and translate, scroll down and find the cityGML version 4. Click details and download. But first, you have to make sure you already registered to this homepage and login. Otherwise, you will not be able to download the cityGML 3D model. After the data downloaded, go to your downloaded folders. This is my cityGML downloaded zip file. So I just double click and unzip the folders. So this is the folders. Inside these folders, there's so many data under the UDX and building folders. So you don't know which one is your study area. You have to go and check index map file, this one. In this case, our study area index code is this one, 50303565. So we go back to these folders, find out the file 3565. So this one, okay. Go back to your QGIS, install the plugin first to import the file, find PLATEAU, just type plate here and PLATEAU QGIS plugin to import the PLATEAU 3D city model data. In this case, I already installed, so I don't need to install again. In your case, you must click install plugin and find the icon, find your data, browse 3565, this one, click open and run. Okay, so now we have a building with information of measurement heights. Here they have information of the measurement heights above meter above sea level. Okay, this is in the unit is in meter. So if you want to visualize in 3D, so you need to make some modification first. Okay, make sure the data is in UTM. Otherwise, okay, let's make sure here. We will not be able to make a 3D map view if the data is not in UTM. Okay, so this is our new 3D map. We will delete first. Just remove like this. Okay. Now double click on your data. Okay. Go to 3D view. Go to rule base. Create a new rule base. Click on this icon. In this case, just type measurement like this. And then select some operators. Let's say building higher than 10 meters is dangerous if there's a typhoon. So larger than equal 10 like this. Okay, and you may change the color if you want to do. Yeah, just select the colors, click apply. Something like this. Then you can go back to view, 3D map view and new 3D maps. Now we can see which building higher than 10 meters and located inside the path buffer area of Typhoon Nanmadol. So you can see here, just control or command and you can change the visualization like this using the 3D view. Okay. Or if you want to make some intersection based on this data, we can do the same thing. Intersection based on the building and buffer. Okay. you will see there's some notification here. There is invalid feature filtering. So we need to fix this polygon first. Just type fix in the processing toolbox and select fix geometry, input the building, and just click run. Okay, so we have a fixed geometries here. If you uncheck the building, we go back to intersection, fixed geometry as input layer, and overlay layer is buffer. We run again. So there is no notification. Okay. Now we have the building from the Minister of Land, Infrastructure, Transportation, and Tourism with measurement height, and located within the path of Nanmadol of year 2022. So based on this data, we create again the 3D view using rule base, measurement heights, go back to operators, larger than equal to 10 meters. Okay, give the colors another color, apply, okay. And then go back to view. On the view here, we need to remove the existing 3D view map. View, 3D view, new 3D map view. Now we have the building with height more than 10 meters located inside the path of 300 meters buffer of Nanmadol. Okay, so that's all for the basic vector geoprocessings and 3D visualization. Thank you.